Hello, and welcome to Summarize Science. Have you ever wondered how a robot could look at a picture of a finished Lego model and figure out, step by step, how to build it? That's a huge challenge in robotics, but groundbreaking new research is making it a reality. Existing robot AI can handle simple commands like pick up the red block, but they often get lost when faced with long-term goals that have a specific, defined outcome. They can see the final destination but have no map to get there. To solve this, researchers have developed an incredible new model called ManualVLA. Think of it as a robot that can write its own IKEA instructions on the fly and then follow them perfectly. ManualVLA's architecture has two specialized parts working in harmony, a planning expert and an action expert. The planning expert looks at the current situation and the final goal image. It then imagines and generates a mini manual for the very next step. This manual is multimodal, meaning it's not just text. It also includes a picture of what to do next and the exact coordinates for where to place the object. The action expert then takes this self-generated manual and translates it into precise physical movements. To teach the planning part of the AI, the system needed to learn from tons of examples. Instead of creating these all by hand, which would be incredibly time-consuming, the researchers built a sophisticated digital twin of the real world. This virtual environment used a technique called 3D Gaussian splatting to automatically generate thousands of photorealistic training examples for the robot. And the results are nothing short of amazing. When tested on complex, long-horizon tasks like 2D and 3D Lego assembly, ManualVLA was far more successful than previous top models. In fact, it achieved an average success rate 32% higher than the prior best methods. You can see from the visualizations that the robot is able to reliably follow its own plan to complete the build. What's more, the system isn't just a one-trick pony. It demonstrated strong generalization, meaning it could still perform well even with unseen object shapes, different backgrounds, and changing lighting conditions. It also excelled in a standard simulation benchmark, succeeding at a wide variety of general manipulation tasks. So, to recap the key points, ManualVLA is a new AI that allows robots to infer the how from the what. It achieves this by internally generating its own step-by-step multimodal manuals and then executing them with precision. The use of a digital twin for data generation was also a clever way to make training scalable. This represents a major step towards creating more generalist robots that can understand and perform complex, goal-oriented tasks in our homes and workplaces. Imagine a robot that could look at a picture of a tidy bookshelf and then actually organize it for you. This work brings us one important step closer to that future.